Hi, my name is Oluwasegun. I'm one of the group prime members for the Oncology Diagnostic Insight project, and I'll be running you through what we've been doing so far. My other colleague, Roshan Tapa, is going to join me. Here's the team. Roshan Tapa is the team leader and developer, and Oluwasegun, which is me, the data analyst. Okay, we have the table of content. This is basically what we are focusing on so far. We have the project summary. Generally, what this is an overview of what we are trying to do, what this project is all about. Here's the data set. We got this data set. It's a cancer type data set. It has about 8 variables that contains the area, the cancer type, year, sex, race, and case count, population, and all of that. So this is basically the data set we have been using in this project to gather the insights we can. So we extracted the data set, and next is the summary and feature engineering. All of this part, my colleague Roshan Tapa is going to be explaining further on that. Data cleaning. We got the data cleaned to be ready for use. Here's the univariate analysis. We did something on that too. Now we have the count plot for the top 5 areas, just because we have a lot of areas in the data set, and so we just did like a count plot to show like the 5 top areas. That's majorly our focus, just to make sure that we can grab an insight from that, from the top 5 areas, instead of having a lot of all the analyzing, or from all the areas. There so much, there a lot. We did the bivariate analysis too, the pair plot. Okay, so here we started to use the Power BI to visualize and plot together some of these variables, to give us a meaningful insight. Here we have area and versus the population. We need to know like the types of area, and considering like which area has the highest population, right, so far. And from what we see here, we can see California is the area that has the highest population. Okay, here is the sex versus case count. So we have in the data set, there are 2 categories of sex, which are the male and the female. So from here, we just want to like do an analysis to show like, okay, which sex has like the highest or the lowest. So far shows that from this visualization shows that the female has the highest count generally in the population of the data set we used. We did a multivariate analysis too, and here we want to move over to how showing you basically what we've done so far with the analysis. I'll be taking you through this part also, so stay with me. Here we want to ascertain the cancer type with the highest count of occurrence across the 4 types of races. From the data set, we have 4 types of races, and now we want to ascertain what cancer type is the highest across the 4 types of races. So from this visualization shows that the cancer type with the highest count of occurrence across the 4 types of races is the colon and rectum cancer. So if we're to like give like an insight, if like a health researcher wants to know like the highest cancer type across the 4 types of races, okay, in all of these races it shows that the colon and rectum cancer is the highest. So something has to be done to show like something has to be done to like level down the occurrence of the colon cancer colon and rectum cancer in this set of race. Comparison of cases of cancer type by area. So we just wanted to know like the area that has the highest or the lowest cancer type. So if any the insight we can get from that will show, it's going to be like a good insight for health practitioners and researchers about cancer to know like in that area, okay, which cancer type, you know, comparing just basically comparing the cases of cancer type by area in this visualization. Okay, next is the mean squared error. So my colleague Roshan is going to explain further on this part, and also okay, and this part also disease partitioning algorithm. Okay, I'll just move over to the Power BI dashboard. So basically, this is what we are going to visualize at the end of the day. This is an overview of what our dashboard is going to look like. You know, putting everything together, gathering the information together for you to see what we're trying to say, what we're trying to, put together in a dashboard. It's easier to get an insight from that. It's easier to understand what we are trying to say with this dashboard. Okay, the challenges we faced so far, the use of data variables for analysis, like we don't have so much variables in the data set, so we had to keep doing a lot to make sure we can squeeze out a lot of insight from that, and created visualizations, design a predictive model, and all of that. These are the strategies we used. So recommendation is we load the clean data set into the Power BI tools like that, and so on and so forth. Okay, we've been having internal communications. This is just showing us what we've been doing so far, how we've been communicating within the team. MRP high level task calendar. Here we go. And the milestone review. Woo! What a journey. We started this since December. No, we started this since, actually, we started since last semester. And so far, this is the milestone. This is where we are. The project costs, we can see from this visualization. And this is our YouTube URL. Okay, so far that's what we've got. Thank you very much for listening, everyone. If you have any questions, you can direct your questions to us. Thank you very much.
Hello everyone, it's me Roshan Thapa, the team leader and developer for our project Oncology Diagnostic Insights. Firstly, I want to thank Oliver Segun for giving insights about what the project is about, its objectives and expected outcomes. We just had an overview about the work we did on this project, applying all the skills and techniques that we learned throughout the semester and this big data course. Now I would like to jump in our IDE Jupyter notebook to demonstrate our work. So firstly, we imported the necessary libraries, NumPy, Pandas, Matplotlib, and we read our dataset from our local machine, that is cancer.xls. Here we can see the top 5 data and the last 5 data. So this is the summary of the data set, cancer.info. We did some feature engineering, separating the start year from the year, dropping row, replacing data set and data not presented with name value. There were many missing values, so we did data cleaning, dropping rows with missing values, converting the column to integer type. We can see that some variables is adjusted rate case count are of different data type, so we did those conversions. So after the conversion, we checked the summary, so we found out it good. When we checked again, we did the top 5 and last 5 data sets, so we found it very nice. So we did some univariate analysis, checking unique values, checking null values, finding the statistical summary of the numerical data type and the categorical data type, determining the categorical variable and the numerical variables. We did the univariate analysis for the numerical data type, calculating the skewness, which gives the summary statistic to describe the shape of the data distribution. Here we can see the plot. This plot describes that the data are positively skewed with some outliers, so we need to clean it for further analysis. Later we'll go into the um, data analysis of categorical variable. This is the box plot. A categorical variable analysis with the area and its frequency. We found out the California has the highest frequency. By variate analysis, this is the pair plot. By variate analysis with the two variables to show the dependency among the variables, area versus case count describes which area has the highest case count. This case test O has the highest case count, almost 7,000 case counts. Area versus population, which area has the highest population. California has the highest population. Cancer type versus case count, which cancer type has the highest case count. We can find that the colon and rectum has the case count more than 5,000. Um, Cancer type versus age assisted rate. Race versus case count, which race has the highest case count. White non-Hispanic has the highest case count. Race as adjusted rate. Sex versus case count, we have two sex categories, male and female, so we can find that the female has the highest case count. This was the heat map describing the multivariate analysis. Now we came to the business question part. Always earlier gave a nice description about these parts, so I'll just go through it. We first did this in our Power BI analysis, and then went into the coding implementation. Here we have used bar graph to demonstrate the business question one. The second business question, we used pie chart. We try to use different charts so that we can analyze properly, and also that fits according to the variable. Scatter plot, 6 categories, the highest cancer type. Bar graph for 6 categories, the highest cancer type. Comparison of cancer type by area. This is also a bar graph with the color differentiation, and for the cancer type. It is really a nice graph. Comparison of cancer cases by cancer. This is also a heat map. For the male type, cancer type with the highest male type. Bar graph. Donut. This is a radar chart for distribution of total case count by cancer type. Donut chart. Yeah, so mean square error for predictive model design. It evaluates the performance of a predictive model and measures the average square difference between the estimated values and the actual values. So we took two variable case count based on cancer type and went through the 5 iteration to obtain the different values and design a graph to pick the best model. So we found out that the iteration one, that is the first model, is the best model for our analysis to design the predictive model. So case count based on 6, we again tried with another variable, case count and 6. Here also we found out that the first model was the best model for our predictive model design. So it concludes that the first model will give us the predictive model design in a good way. Decision partitioning algorithm, we went through some research and found out that this algorithm, decision partition algorithm, is suitable for our project and for further analysis. Partitioning algorithm is a way of sorting data into different groups based on specific characteristics related to the illness. So as our data set is related to the cancer type, so we chose the data set. We for this process we chose the cancer type and applied the algorithm and obtained the summary statistic for different cancer types. Each cancer type, which gives us an view of each cancer type, like count, mean, standard deviation, and maximum values. So yeah, these are all the works that we did throughout the semester, and until now I'd like to conclude this video by going once that use Jupyter notebook as our IDE, loaded data set, data cleaning, data analysis, multivariate, univariate analysis, business questions, Power BI implementation into code implementation, predictive model design with uh, mean squared error and applying disease partitioning algorithm. So for finals presentation and for future, we'll be doing Power BI dashboard, Power BI dashboard, a dynamic one. So that's all. Yeah. Thank you.